parent matrix does is it inherits one motion to another motion. So if we were to connect our child link position here for the parent matrix to our torus matrix, what would happen is our camera matrix is now inheriting all of the information from our torus matrix. So if we go to the animation section and take a closer look at that, what you can see is whenever I move my torus objects around, the camera is also moving because it's also inheriting all of this information. The same with rotation. Whatever we move and rotate our torus around, that information is also being passed across to our camera. Now, while this is really useful, what you can see is that things are beginning to get a bit messy here. You're seeing links going from one object to another, and as a project increases in size, this would become very messy. So this is where another feature in Quest comes in very useful. You can actually create a shortcut from one place to another without having to have a link. So if I select, for instance, the motion here of our torus object and right click it and then click create shortcut, you can see another channel has appeared here. Now basically this is just a shortcut to that channel here. So what I can do is replace our link with our shortcut here, and you can see now it's much neater. There's no lines going between the different entities here. We've now finished our introduction to the channel section. One aspect of the channel section which we haven't covered yet is saving. We're going to cover saving in the next tutorial when we start to actually build a project. Let's now take a look at the animation section. Let's now go to the animation section and show how this can be useful. So if we zoom out, exactly the same controls as in the channel section, you can see that we have our torus objects and our camera, and you can see the light as well, all represented by icons here. Now these icons, the size of these icons can be changed by using the plus and the minus buttons down here on the bottom left. So if I press plus, you can see the icons become smaller. If I press minus, they become bigger. This is effectively scaling the world size up or down. So you can also see our object here has a gizmo. Now this is really useful for moving our objects around. You can still use the values here, all the values in the channel section to move your object, but often it's much more convenient and much quicker to get correct positioning by using the gizmo instead. So you can see I can move it around here. If I go into rotate mode, you have a rotate gizmo for it as well, and you can see because our camera is still parented to our torus, you see all of this stuff that I'm doing to our torus is also manipulating our camera. So if we go back to the channel section now, and let's take this off so that our torus is no longer linked to our camera like that, we can put it onto the lookup matrix instead. So now you can see our camera will just look at our torus wherever it goes. It's also possible to turn the gizmo off by using this two tabs down in the bottom left here. So now we've turned our gizmo off, you can still move the object by moving the mouse or by using the values here. So at the moment I'm moving my object using the mouse. Now you can lock these values here if you want to. So you can see now I'm restricting the movement only to the x-axis, and I'm moving the object by holding the left mouse button down and by moving the object left to right. If I lock the x-axis and unlock the z-axis, you can see I can do exactly the same there, and for the y-axis I have to use the right mouse button. So I'm now holding the right mouse button down and moving the mouse up and down. So this also can be very useful when you want to constrain your object to move only in a particular axis. We'll now take a look at the object section, first focusing on materials. Now, the object section is where you can define the visual properties of your object. In this section, you only see the selected object in the window here, so it's isolated and easy for you to change its properties and see it in full view. Now on the left here, you can see the first thing we have is its material properties. Now, the diffuse channel here basically affects the way that a light will react with the object. So at the moment, our diffuse color is set on full. That means that it's going to give a white color in a bright light. If we turn it down, you can see the color change, and you can pretty much get any diffuse color you like by just using these sliders. The next one down here is the emissive. Now emissive is just self-illumination. So this is how the object will look irrespective of there being a light present or not. So if I turn this up to full, you can see our object is always white, no matter whether there is a light there or not. The specular sliders define how much specularity there is on your object. You can see as we turn the sliders up, the amount of specularity increases. Specularity is directly linked to the light's position. The specular power function just defines how tight the specularity is. So it can become very, very tight if we turn it down there and give this up, so you get very intense specular highlights, or you can make them much broader by using it like this. Alpha, now this is if you've chosen transparency for an object. At the moment we haven't defined any transparency, but if you do, you can use this slider to increase or decrease the amount of transparency. Let's now take a look at how you can apply textures to objects. On the right hand side here we have our Textures tab. Now this defines the way textures work on an object. So if we go to the Textures tab here, you can see we can hit the load button and load a texture into our project. So if we find a texture from your hard drive, you can then literally, just by having the object selected and clicking on the texture, you can apply it to your object. So you can see we now have that texture applied to our object. But what if we want to change the way that it works with our object? Well, first of all, we've got our mapping coordinates. Now at the moment it's using default mapping coordinates. So these are the mapping coordinates that are inherently on the object, or if you had imported an object, these would be the mapping coordinates that you had defined for that object. So let's now define some mapping coordinates for our object. Now I need a bit more space because I'm using such a low resolution to capture this video, so you can see a little bit more interface now. So what I'm going to do here, let's try for instance qubit mapping, and let's give it a bit more tiling. So you can see we've now created 4 tiles in each direction, and you can see now that our texture is appearing on our object. At the moment you can't see it so well though because of the stuff we've done over here. So let's turn its diffuse up to full and its specular down to 0. So now you can see it much more clearly, our texture on the object. Now as well as just applying the texture to an object, you can also adjust the way in which it's shown. Now you can see here in this section you've got a series of arguments and operators. Now this is really quite advanced stuff, but basically by using these arguments and operators you can define very complex ways in which the textures interact with each other, because you can also apply several texture layers and you can change the way in which these layers interact with each other by using all of these color blending and alpha blending modes. So we'll look at this again a bit more later on in a more advanced tutorial. If we wanted to have some transparency on our object, we can go over to the surface section here. Now in the surface section we've got lots of different options for transparency. These all have different ways of working out how the transparency should be. Now the simplest way is just to use alpha value, and if we select alpha value from here we can go back to our properties and use our texture factor to define how much transparency is. If we didn't have a texture applied, we would be using the alpha value to define how much transparency there is, but because we do have a texture here, we're now using the texture factor. We will look at more of the in-depth options for transparency and some of the other options here in the advanced section later on in one of the more advanced tutorials. But for now this should cover the basics of how the program works. We started this tutorial by looking at the interface of Quest3D. We then had a look through the channel section, then moving on to the animation section, and finally we looked at the object section. In the next tutorial we're going to build a scene. We'll start off by looking at how you can import objects into Quest3D. We're then going to look at how to use textures with an alpha channel. Then we'll move on to using multiple texture stages to create more interesting looking objects. We'll then look at using reflection maps, adding light maps to an object, and then finally using a walkthrough camera so we can navigate through our scene.